Hey Yahoos, we are checking out 3-1 number sets. It's a new unit, a new dawn, a new day, a new life for me. All right, so number sets are sort of thinking about grouping. So I want you to think about how many different ways you can group these. I think this is a frog and a rhino and a wolf and a few other things. Can you group them? Maybe you have the cutouts there. Maybe you just need to think about grouping them in whatever different groups make sense. Think about that and pause me for a little bit. Okay, well maybe we could do some things like here. These are grouped together. These are kind of swimming animals. These are kind of exotic animals, like you don't generally see them around. Oh, I have two toads. Huh, okay. These are amphibians. That's a spider. These are kind of like household pets. Maybe a bird. Those are more domestic. There's a person. You can kind of group them. That's a plant. Kind of group them like that. You could group them with like these have maybe by legs. These have 4 legs. These have 4 legs, 4 legs, 4 legs, 4 legs, and these are 2-legged animals. You could group them, and that's a plant. You group them kind of like that. You could group them like this, those that cannot fly and those that can fly, things like that. Here's maybe a more specific way. If you had something like this, you could maybe group them by saying, oh, this is kind of the oddball out, this leaf. It's kind of a plant, but aside from that, everything else is an animal. So I'm going to put all this inside here like that. And within that circle, some of these happen to be, well, like this jellyfish and the rhino are very different animals. This is not an animal, so it's outside. But like this doesn't have a backbone. It's an invertebrate. And all of these others are vertebrates. Oh, except the spider. The spider is an arachnid. They have an exoskeleton. Exoskeleton, meaning they are not vertebrates. They don't have a vertebrae. So this is maybe like invertebrates. Invertebrates is this circle, and maybe this circle is vertebrates if you have a spine. And this is a plant. This is not an animal, right? And then within there you could say, well, some of these are more like us. They're mammals. So like that's a mammal, dog's a mammal, pig's a mammal. Oh, that's not a pig. Pig's a mammal, cat's a mammal, monkey's a mammal. Oh, person's a mammal, and rhino is a mammal. And the rest of these are indeed vertebrates. They have a spine. If you open them up, they have a spine, but they are not. Mammals, right? They don't produce live young, and they. What else do mammals do? They have mammary glands, right? And within there's a certain subset in there that actually has a few other traits, and these you might call primates, right? We have mammals, but we have other things in common, like how we group ourselves and. Let's see, what makes a primate? That's a good question. These are primates. I'm going to go ask one of our I'm in the biology lab. Should ask the biologists. So there's a way that you could maybe group all of these things, right? Like that. Ooh. And you can see that the vertebrates, these are vertebrates, and these are vertebrates, and these are vertebrates. But within the vertebrates, so like a person classifies both as a vertebrate, as a mammal, and as a primate. Oh, maybe I should do this. This bigger circle wasn't invertebrates. The bigger circle should have just been animals. The bigger circle should have been animals. Animals. By virtue of them not being in the vertebrates, they're in the invertebrates, and the plant was outside. So these are primates, these are mammals, these are vertebrates. And you can see that the ones on the farthest on the inside are parts of the vertebrates, parts of the animal. And so these are what we call sets and subsets, because this is a set of animals, and within there are subsets. This is a subset of animals, and so vertebrates are a subset of animals, mammals are a subset of vertebrates, and primates are a subset of mammals. And that's kind of, you already know that sort of lingo. That's what we're checking out today, is just how to start talking about them. So at the top of your notes, you can put 3-1 number sets and jot these notes down. So a set is just a collection of things. Sometimes, mostly in math, we'll talk about them as numbers, but sometimes you can talk about them as objects, like animals. Each thing is called a member or an element. And we talk about them with these fancy curly brackets when we're talking in algebraic terms. We use a capital letter, so we can talk about them easily, and you list everything in there. So factors of 12, for example, is like what 12 is divisible by. It's divisible by 12, 6, 4, 3, 2, 1. So you'd say F as factors, and here's all the things that 12 is divisible by. That's a set of numbers. Within there's a subset. A subset could be even numbers. We'll get to that in a second. But set notation is just how you write things. So this little guy looks like kind of like an E. It's like a C with a. This just says is an element of, or is in. And if you put a slash through him, it means he's not in. So you could say 5 is not in F, because I don't see 5 in here. 12 is not divisible by 5, so 5 is not a set, an element in F. But you could say 2. 2 is in F. 2 is a factor of 12. There it is. If you have nothing in there, like sometimes you can have what they call the empty set. It doesn't mean 0 is in there. For example, like if you said, we want something that's empty set. I want all the factors of, let's see, what's in the empty set. How about this? Students in the room right now. You see anybody? Not that guy, but students in the room. Right now, there's no students in the room, so S is the set of all the students in the room, and so it would look like this right now. No one. It's not the number 0, because there's not a dude in here named 0. 0! Are you here? No, right? So there's not a student called 0 in here. Zip! So we would have to say there's nothing in this set of students in the room. You'd use this slash an O with a seatbelt. This is the empty set. Now, if you said teachers in the room, this would be just me. Yeah? Just me. But it's not no one. So empty set is 0. 0 people, but this means no one's here. You don't put a 0 there. You say this is the empty set. There's nothing in there. Yeah. And NS is the number of elements in the set S. So here, the number of elements in the set T. So you'd say the number in the set T is 1. It's just me. Wah, wah, wah. For the students, you'd say the number of elements in the set of students in the room is 0 because there's no students here. That's why this empty set occurs. So I know this is a little bit technical, but that's why we're doing this. Let me just get my. So if F is the set of, going back to this original one, it's all the factors of 12. Here's all the factors of 12, the set of. You can say 4 is an element of it, 7 is not an element of it, and the number of elements in F is 6. 1, 2, 3, 4, 5, 6. Right, there's 6 things in there. Cool, just technicalities. Well, all right. Move your head, Yorkevich. Move your head. Subsets is what we were talking about before. It's saying that it's a smaller group within the bigger group. And so all of these primates, this is the group of primates here. All of the primates are also mammals. So you could take this away and have it make sense, right? These are still all mammals. But within there, there's a smaller group which belongs to the whole group but is a little more select. And you can see that gorillas still is in both. Human is in both. Monkey is in both. Right? And so we use this notation. This says a subset. So primates are a subset of the mammals. Does that make sense? So for example, here's a set of numbers A, here's a set of numbers B, and you can see that 3 is in both, 8 is in both, so you could say A is a subset of B. It's like there's A is fully in B. Cool, so A is a subset. Great. Subsets. All right, disjoint sets, sometimes we call mutually exclusive. It's when they don't have anything in common. Yeah, when there's no overlap. So if you rolled a die, you could get a 1, a 2, a 3, a 4, a 5, or a 6. Here are the even numbers, and here are the odd numbers. Let's call them P and Q. So you could say the disjoint sets, there's no overlap. You'd say P, this upside down guy, it's called the intersection. Intersection. That guy. So the intersection of P and Q is not equal to 0. That means 0 is in common. This means it's empty. There's no overlap. Because here and here, no overlap. Where in here, you'd say there's overlap between A and B. A and B overlap. Yeah, so you'd say the overlap, the intersection of A and B is just what they have in common. It's 3 and 8. Sorry, I'm writing with my finger. Never mind. Cool. So I like this. Guys who want to date me and guys who I want to date, no overlap. So the intersection is denoted with this guy, like that. All right. Union and intersection. So this is what we were seeing before. The intersection is denoted by an upside down U. It has to be both P and Q. It has to have both things happen. Similarly, if you use a right side up U, makes me think of it's union. I remember because they both have U's. And it needs to have either P or Q or both. It needs to be one or the other. Both is okay too. I'll give you some examples. So let's say here's P, here's Q. They're just number samples. The intersection of P and Q, this means I need both of them to happen at the same time. This intersection. I need them to be in both. So I see a 2 is in both. I see a 5 is in both, and I see a 6 is in both. So 2, 5, and 6 are the intersection. For the union says, I want numbers that are in P, in Q, or in both. And so all of them, this is 0, 1, 2, 3, 4, 5, 6 is in both, 7's over here, 8's there. These are all the numbers. For example, you could be in physics. So like if physics is Tom and Darlan and Finty. Those are who's in physics. It'd be faster if I typed them, huh? So if physics was Tom, Darlan, and Finty, and when you decide, you get to decide which classes you're going to take in 11th grade. And if you were also in art, it's conceivable that Derek, Darlan, and Nayla are in art. So this intersection would be who is doing both, who is a physicist and an artist at the same time, and it would just be Darlan. The union would be who is in physics or art. I need help with physics and I need help with art. Who can help me? Well, Tom and Darlan and Finty can help with physics. Derek, Darlan, and Nayla can help with art. Darlan's on there twice, so I'm not going to like send her 2 emails, but she's definitely in the set. So the set of physics union art is going to be Tom, Darlan, Finty, Derek, and Nayla. Right? Those are all the people that can help you with physics or art or both. Cool. Okay. Trial by fire. That's how I answer every true or false question. Trolls. Try this. Here's 2 sets, A and B. Tell me true or false. And I'm not going to read these to you right off the bat, but I'll read them to you, and I think that'll make it easier to see what they are. Okay, try those out. Pause me and give it a shot. Okay, so our sets are A and B. I want to know, is 4 an element of B? Is 4 an element of B right there? Yeah, looks like it. So yes, true. Ching, is 4 not an element of A? You see any 4s in there? No. So 4, yes, is not an element of A. So that's true also. So list the set, the A intersection of B. I want to see what overlap there is between A and B. This is this is intersection. So what do I see in common? 3. 3 is common. No, 5, 7. 7 looks to be common. Did I miss any? I think 3 and 7. So you'd say the intersection is 3 and 7. A intersection equals bracket 3, 7. This is the way you need to write it down, right? You can't just leave that. That's a point in space. This is a set. And so that's the way that I want to encourage you to keep writing these down. Okay, and so then write down list the set A union B. It would be everything that's in A, everything that's in B, and everything that's in the overlap. So it's all of it. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 11. Yes, 3 and 7 come up twice. Don't list them twice. It just says what's here. It's in A, it's in B, there's overlap, but that's okay. Okay, true or false? The intersection of A and B is a subset of A. Is the intersection of A and B. The intersection of A and B are 3 and 7. Is that a little piece of A? Is this a little piece? Is this a subset of A? Well, yeah, look. It's here and here. This 3 and 7 is all within A. So yeah, this is a little subset of A. Great. Let's try that with this second part. Is 3, 6, and 10 a little subset of B? Well, there's 3, there's 6, there's no 10 there. So 3, 6, 10, this little subset, this little group is not a subset of B. No way, Jose. Bing. Cool, so false. All right, that's what I want you to play with. I want you to be careful about how you write things down. That's what matters here in number sets, and we're going to use that as we go. Cool, there's some practice problems in your home learning. Looks like this. It's 3, 1, and you're going to do front and back. There's answers on the back. Check them out. Cool.